Can nanotechnology unlock deep space exploration for humans? Imagine a future where tiny machines and materials at the scale of atoms could help humans explore the farthest reaches of space. That's what nanotechnology aims to do. It involves working with materials so small that they are measured in billionths of a meter. This tiny scale allows scientists to create new materials and devices with special properties. For space travel, this could mean making spacecraft lighter, stronger, and more adaptable than ever before. One exciting possibility is using nanomaterials like carbon nanotubes and graphene. These materials are incredibly strong yet lightweight, which means spacecraft can carry more supplies or travel farther without increasing launch costs. For example, a spacecraft built with nanomaterials could be half the weight of traditional designs but just as durable. This could cut the cost of launching into space significantly and make long missions more feasible. Another strange but useful idea is self-healing materials. Imagine a spaceship hull that can repair tiny cracks caused by micrometeoroids or radiation damage all by itself. This would reduce the need for heavy spare parts and risky repairs in space. Scientists are working on nanoscale mechanisms that could automatically fix these tiny damages, keeping spacecraft in good shape for longer missions. Nanotechnology also offers better ways to shield astronauts from cosmic radiation. Nanoscale coatings and composites can absorb or reflect harmful particles more effectively than traditional materials. This could protect crew members and sensitive electronics on journeys to Mars or even farther. Better shielding means safer trips and longer stays in space. Tiny nanosensors are another tool that could change space exploration. These sensors can monitor conditions inside spacecraft like temperature, pressure, and radiation levels. They can also detect water or chemicals on other planets. Because they use less power and are so small, they can be placed everywhere, providing real-time data to keep astronauts safe and missions running smoothly. Some scientists are even working on nanorobots. These microscopic machines could extract water, minerals, or fuel from asteroids or planetary surfaces. This process, called in situ resource utilization, means humans wouldn't have to carry everything from Earth. Instead, they could produce what they need right where they are, saving space and money. Nanotechnology also improves space robotics. Tiny sensors and actuators made with nanomaterials can help robots operate more reliably in harsh environments. When combined with artificial intelligence, these robots could repair satellites or explore distant planets with minimal human help. They could even perform tasks that are too dangerous or difficult for humans. Managing heat is another challenge in space. Nano-engineered heat shields can better distribute and dissipate heat during atmospheric entry. For example, adding tiny carbon nanofibers to heat shield materials creates a passive heat pipe effect, moving heat away from critical areas. This not only keeps spacecraft safer but also reduces weight. From strange experiments in labs to real future tech, nanotechnology is opening doors to new possibilities. Imagine spacecraft that heal themselves, tiny robots mining asteroids, and sensors that detect cosmic dust invisible to the naked. These ideas may seem like science fiction now, but they are becoming real as scientists learn how to control and use materials at the nanoscale. In the end, nanotechnology has the potential to change how humans explore space. It could make spacecraft lighter, safer, and smarter, and help us reach places we once only dreamed of. While many of these ideas are still in development, their strange and surprising behaviors at the nanoscale could be the key to unlocking the future of deep space travel.